This is my 8th video lesson for Unit 15. In this lesson, we'll be analyzing organic reactions. Go to page 32 in the class packet. Learning target. At the end of the lesson, I'll be able to identify and analyze organic reactions. Homework be number 8, which will be a junior pod based off this lesson. There'll be a quiz junior pod on PowerPoint 678. Organic reactions are chemical reactions that involve organic compounds. There are 8 organic reactions that you need to be able to identify and describe: addition, substitution, fermentation, saponification, esterification, combustion, and polymerization, addition, and condensation for the Regents exam. We will go over each one. Addition reaction is when 2 or more reactants combine to form a single product. Let's look at an example. Here we have ethene reacting with chlorine to form 1,2-dichloroethane. Notice that the double bond of the ethene was replaced with 2 new single bonds. The 2 chlorine atoms are inserted into this molecule. This is similar to a synthesis reaction. In summary, an addition reaction involves an unsaturated hydrocarbon becoming a saturated hydrocarbon. Let's analyze and compare the reactants and the products. There are 2 reactants. One is an unsaturated hydrocarbon, an alkene. The other reactant can be a diatomic or binary molecule. Let's look at the products. There's only one product in addition reaction. It is a saturated hydrocarbon parent chain with 2 new atoms. In substitution reaction, an atom or functional group is replaced by another atom or functional group. Let's look at an example. Here we have ethane reacting with bromine to form bromoethane and hydrogen bromide. This substitution reaction involves a saturated hydrocarbon and a diatomic molecule. One bromine of the diatomic molecule switches places with one hydrogen from the hydrocarbon. That's how we got bromoethane and hydrogen bromide. This is similar to a double replacement reaction. Now let's analyze the reactants and products. There are 2 reactants. One of them is a saturated hydrocarbon and it reacts with another molecule. There are 2 products. One is a saturated hydrocarbon with a new substituent and HX. Learning check number 1. Base your answer to the following question on the organic reaction below. This reaction is an example of what? Pause the video. Resume as completed. This organic reaction has 2 reactants and 1 product. The Br2 is inserted into this molecule. 2 new single bonds are formed and the double bond disappears. Therefore, this is an example of an addition reaction. Choice 2. Learning check number 2. Given the reaction, which type of reaction does this equation represent? Pause the video. Resume as completed. The equation has 2 reactants and 2 products. 1 atom from each molecule switches places. Therefore, this is an example of a substitution reaction. Choice 4. Learning check number 3. As an addition reaction occurs, the number of electrons shared between the carbon atoms do what? Pause the video. Resume as completed. Let's analyze an addition reaction. In the reactants, there is a carbon-carbon double bond, which is 4 electrons. In the products, the carbon-carbon bond is a single bond, which is 2 electrons. Therefore, the number of electrons decrease. Choice 1. Learning check number 4. As a substitution reaction occurs, the number of electrons shared between the carbon atoms do what? Pause the video. Resume as completed. Let's analyze a substitution reaction. In the reactants, there is a carbon-carbon single bond, which is 2 electrons. In the product side, the carbon-carbon bond is a single bond, which is also 2 electrons. Therefore, the answer is choice 3. It remains the same. For practice number 1, identify if the following reaction is addition or substitution. Try to do this yourself. Pause the video. Resume as completed. Here are the answers. In fermentation, the enzymes in the yeast breaks down the sugar into alcohol and carbon dioxide gas. In this example, glucose is the sugar and ethanol is the alcohol. The enzymes in the yeast serve as a catalyst which breaks down the sugar into 2 ethanol and 2 carbon dioxide molecules. The atoms are color-coded so that you can see that the log conservation of mass is observed. Alcoholic beverages are formed by yeast. It forms as a result of the enzymatic breakdown of organic molecules during anaerobic respiration. This process is called fermentation. Let's analyze the reactants and the products. In the reactants, we have glucose, which is sugar, which reacts with yeast, which serves as a catalyst. The products are 2 ethanol and 2 carbon dioxide molecules. In saponification, it is a reaction of a fat with an alkali base to form glycerol and soap. Here's an example of a fat. This is triglyceride. The fat molecule will react with an alkali base. In this case, it will be 3 molecules of sodium hydroxide to form 1 molecule of glycerol and 3 molecules of soap. In summary, saponification is the hydrolysis of fats by base. A fat is an ester. This triglyceride molecule has 3 ester groups. The reaction produces an alcohol and soap. Glycerol is considered an alcohol because it has 3 OH groups. Ester bonds are broken in the fat. Here are the 3 ester bonds that are broken during the reaction. Let's analyze the reactants and the products. The reactants are fat and base. The products are glycerol and soap. Learning check number 5. What are the products of a fermentation reaction? Pause the video. Resume is completed. The answer is choice 2, and alcohol and carbon dioxide. Learning check number 6. The principal products of saponification, a reaction between a fat and a base, are soap and what? Pause the video. Resume is completed. The answer is choice 2, glycerol. The next organic reaction is esterification. This is a reaction between organic acid and alcohol. This produces an ester and water. This is the water-forming portion. If you look at the ester, this fragment came from the organic acid, and this fragment came from the alcohol. On the Regents exam, you must be able to figure out the ester from the alcohol and organic acid. In summary, the reactants are organic acid and alcohol, and the products are ester and a water molecule. Learning check number 7. A reaction between an acid and an alcohol produces an ester and what? Pause the video. Resume is completed. This is describing an esterification reaction, so the answer is choice 2, water. Learning check number 8. A reaction between CH3COOH and an alcohol produces an ester, CH3COOH CH3. Which alcohol was used in the reaction? Pause the video. Resume is completed. By looking at the ester, this fragment came from the organic acid. Therefore, this fragment must come from the alcohol. Since the alcohol fragment has only 1 carbon, the answer is choice 1. Learning check number 9. Which compound will react with CH3COOH to form the ethyl ethanoate? Pause the video. Resume is completed. Ethyl ethanoate is an ester, and this is organic acid. Therefore, this is describing an esterification reaction. The compound that will react with the acid will be an alcohol, so choice 1 and choice 2 are wrong. To figure out the alcohol, we have to analyze the chemical name of the ester. This represents the parent chain, which has 2 carbons. This represents the R group bonded to the oxygen. Ethyl means 2 carbons. This fragment refers to the alcohol, which is 2 carbons, so the answer is choice 4. Combustion is an exothermic reaction involving a hydrocarbon and oxygen. This makes carbon dioxide, water, and energy. In summary, the reactants for combustion reaction is a hydrocarbon and oxygen, and the products is carbon dioxide, water, and energy. The last organic reaction that we're going to cover is polymerization. It is when many identical small molecules, called monomers, are chemically joined together to produce a long molecule called a polymer. A monomer is a molecule that is a single basic unit of a polymer. A polymer is a large molecule consisting of many repeating units. Here's a diagram illustrating the monomers being bonded together to form the polymer. Think of the polymer as a chain with each of its links a monomer. There are two types of polymerization: addition polymerization and condensation polymerization. If you look for the similarities between these two equations, they both have N and a bracket. N stands for the number of units or monomers. If you see a bracket and N in the chemical equation, it should tell you that it is a polymerization reaction. There are two types of polymers, natural and synthetic. Here are some examples. Protein is a natural polymer. Amino acid is a monomer. Starch is a natural polymer. Glucose is the monomer. For synthetic polymers, nylon is used for clothes and Teflon is used for nonstick pans. Take a moment to watch a TED video about polymerization. Once you watch the video, resume this one. In addition polymerization, the polymer is formed by chain addition reactions between monomers that contain a double bond. If we look at this example, this monomer is ethene. It has a double bond. When ethene undergoes addition polymerization, it forms polyethylene, which is the polymer. Notice that the double bond is gone now. In summary, for addition polymerization, for the reactants, you have an unsaturated hydrocarbon monomer times N, and for the products, it is a saturated hydrocarbon polymer. When N is equal to 2, you have two monomers reacting together to form a polymer. If N is equal to 3, you have three monomers reacting together to form a polymer. If N is equal to 4, you have four monomers reacting together to form a polymer. For condensation polymerization, forming a polymer results in the loss of water, H2O. There are three types of condensation polymerization. The first type is a polyether. The monomer is an alcohol, and the polymer is an ether. Next is a polyamide. The monomers are linked together by forming an amide bond. An example of this will be forming a protein from amino acids. The amino acids form the peptide by making an amide bond, which releases water in the process. The last type is a polyester. There are two monomers. One of the monomers have organic acid function group on both ends, and the other monomer have an OH group on both ends. To make a polyester, the monomers will undergo multiple esterification, forming multiple ester bonds. What is common in all three types is the release of water. This is the feature of condensation polymerization reactions. Learning check number 10. The process of joining many small molecules into larger molecules is called what? Pause the video, resume as completed. The answer is choice 2, polymerization. Learning check number 11. A condensation polymerization reaction is best described as the what? Pause the video, resume as completed. The answer is choice 2, joining of monomers by the removal of water. Learning check number 12. Which reaction is used to produce polyethylene from ethylene? Pause the video, resume as completed. The chemical formula for ethylene is C2H4, which has a double bond. So the answer is choice 1, addition polymerization. Learning check number 13. Which type of reaction is represented? Pause the video, resume as completed. This reaction produces ether and water, so the best answer is choice 1, condensation polymerization. For practice number 2, identify the type of organic reaction that best represents the chemical equation. Try to do this yourself. Pause the video, resume to complete it. Here are the answers. This concludes the video lesson. Remember to do the Junify homework and quiz.